Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. So today we are going to continue with our chapter 6, chemical equilibrium, with the last subtopic, chapter 6.3, Chatellier's principle. So we are going to cover a few learning outcome for today. The first one is we are going to look at what is Chatellier's principle, and then we are going to apply the Chatellier's principle to explain the effect of the following factors on a system at equilibrium. Which the factors number 1 is concentration of reacting species, number 2 pressure by changing volume, number 3 addition of inert gas at constant volume and constant pressure, number 4 temperature, and number 5 catalyst. So let's look at what is Chatellier's principle. So Chatellier's principle states that when a chemical system is disturbed, it reattains equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Okay, maksudnya, in the chemical reaction system, which is already at equilibrium state, but something is add on or remove or increase or decrease in the system, which means that the system has been disturbed. So the chemical system here, it will reattain the equilibrium. It want to maintain the state of equilibrium by shifting the equilibrium position so that to reduce the effect of the disturbance. Okay, so there are 3 common disturbance, which is change in concentration, change in pressure caused by change in volume, and change in temperature. So what is net reaction? So net reaction is actually the shift in the equilibrium position of the system to either right or left. So basically the system will shift the equilibrium position to the left or right so that it can reduce the effect of the disturbance or the effect of changes that has been applied on the system. Okay. So let's look at the first factors, changes in concentration. So, if the concentration increases, the system will react to consume some of it so that it can reduce the concentration that has been increased. Okay, for example, we have PCl3 gas react with chlorine gas to form PCl5 gas. Okay, so we have the QC here, the reaction quotient in terms of concentration, which is PCl5 divided by PCl3 times Cl2. Okay, so here the disturbance is the addition of chlorine gas. So which means that the chlorine gas is more. Okay, there is more chlorine gas in the system, which makes the system is not at equilibrium. Okay, so when we increase the concentration of chlorine gas, the Q is not equals to K. So now, kalau kita tengok daripada chapter 6.2, when there is more reactant, which it means that the Q is actually less than K. Okay, so the system will need to reduce the chlorine gas by proceeding the reaction to the right. Okay, let me show you. What happened if we... So, Okay. So, when we increase the chlorine, the system needs to reduce the chlorine gas. How? It will shift the equilibrium position to the left. To the right. Okay, why to the right? Because when we shift the equilibrium position to the right towards the product, it will consume the chlorine gas. Why? Because the chlorine gas will react with the PCl3 gas to form product. So now the additional addition of chlorine gas will be consumed by the reaction to form product. So now it will consume some additional chlorine. So now the concentration of PCl5 will increase. So this concentration will increase and the concentration of PCl3 will decrease. So senang cerita, the concentration of reactant will decrease, the concentration of product will increase here. Okay, hence the new equilibrium will achieve the Q equals to K. Okay, alright. So, if we see here, okay, so at the original equilibrium, we have Kc is equals to 24.0. Okay, this is the original equilibrium. Okay, this is the new initial just after the chlorine added. So, dia dah jauh daripada equilibrium. So, bila when the equilibrium shift the position to the right, where the PCl5 where it increase the concentration of PCl5 and it decrease the concentration of Cl2 and PCl3 sebab dia orang consume to consume the additional concentration of chlorine gas. So now at new equilibrium, we will still achieve the same K. Maksudnya, here we can say that the factors of concentration does not affect the value of K. The value of K will remain the same. Okay, cuma yang berbezanya adalah dia punya the concentration of the reactant and product when achieve the new equilibrium. Okay, alright, but tak kisahlah original equilibrium ke new equilibrium ke, the value of K will remain constant. Okay, alright. Okay, so at a given temperature, at a constant temperature, Kc does not change with a change in concentration. Yang change hanyalah dia punya equilibrium position dengan dia punya equilibrium concentration. Okay? Okay. Okay, let's look at this one. Okay. We have, this is the Haber process. Okay, Haber process. Where we have a nitrogen gas here, react with 3 moles of water, 3 moles of hydrogen gas to form 2 moles of ammonia gas. Okay, so original equilibrium will have Q equals to K. The disturbance here is we add more NH3. So we add NH3, so NH3 increases. So what will the system do? The system will need to decrease back the amount of NH3. So now, how to reduce the amount of NH3? The equilibrium position will shift to the left so that it can consume the NH3 here. So, to reduce the disturbance, to reduce the increase of NH3, the net reaction will proceed to the left. Okay, so now the new equilibrium will achieve Q equals to K balik. Okay? Alright, so maksudnya dekat sini, the amount of NH3 will reduce, the amount of nitrogen gas and the amount of hydrogen gas will increase. Sebab dia form dia punya equilibrium position shift to the left kan, dia form more reactant balik dia compared to product. Okay? So, next, kita tengok pula kalau concentration decrease. So, tadi kalau concentration increase, sistem akan react to consume some of it. Dia akan reduce lah. However, if the concentration decreases, the system will react to produce some of it. So for example here, okay, we have PCl3 here. So we have PCl3. Mana lagi? Kita punya PCl3 dah decreases. Kita remove PCl3. So now, reactant ni dah kurang lah kan? Betul tak? So what we need to do? The system will shift to the left in order to produce more Cl3. So the reaction will proceed to the left so that now the concentration of PCl3 and Cl2 increases and the concentration of PCl5 decreases. Why? Because it has been used up to produce more PCl3 and Cl2 gas. Okay, sebab sekarang ni sistem ni nak achieve balik equilibrium ni. Sebab apa? Ada gangguan di mana PCl3 ni dia remove. So sekarang ni the concentration of PCl3 dah decreases. So the system will need to increase back the concentration of PCl3 by producing more PCl3. So dengan cara equilibrium position shift to the left in order to produce more PCl3 and Cl2. So by that, it will consume more PCl5. So that is why the concentration of PCl5 decreases. Okay. So the disturbance reduce concentration of PCl3. So now, okay, itulah dia. Okay, so now the new equilibrium will have the Q equals to K balik. Okay? Okay. So remember, if we increase the concentration of product, kalau kita increase concentration of product, dia akan shift to the left in order to consume the additional product added. Okay? However, if we decrease the concentration of product, the equilibrium position will shift to the right to produce some of the product that has been removed. Okay? Same goes when we increase the concentration of reactant, the equilibrium position will shift to the right to consume the additional reactant that has been added. Okay, however, when we decrease the concentration of reactant, the equilibrium position will shift to the left to produce some of the reactant that has been removed. Okay? Alright. So now let's look at the second factors, which is changes in pressure by the changing in the volume of the volume. Okay, so this is only involved in system with gases component. So kalau yang aqueous semua, dia tak akan involve change in pressure lah. Okay, so liquids and solid are nearly incompressible. So pressure changes can occur in three ways. Okay, when we changing concentration of gases component, adding inert gas, or changing the volume of the reaction vessel. So kita akan fokus yang ni, changing the volume of reaction vessel. Okay, let's look at this one. Change in pressure by changing the volume of the gases. So, kita punya gangguan kita, we decrease the volume. So, bila kita decrease volume, kita tekan dia, what happened to the pressure? Pressure increase, betul? So, now the gas pressure immediately increases. Okay. So, now QC will not equal to KC. So, which means the system is now not in equilibrium, not at equilibrium. So, the system will reduce the effect of the disturbance by reduce the number of gas of molecule. So, maksudnya, dia akan shift kepada, shift to the side with fewer moles of gas. Because the fewer moles of gas will exert low pressure. Okay, dia akan proceed to the right. Okay, so bila kita proceed to the right, which means the concentration of PCl3 and Cl2 decreases and the concentration of PCl5 increases. Okay? Okay, so senang cerita, kalau pressure dia increase, sistem akan cari jalan to decrease the pressure. How? The equilibrium position will shift to the side which has fewer number of moles of gas. So in this case, product has a fewer mole of gas. Dia ada 1 mole je compared to reactant 2 mole of gas, betul tak? So to reduce the pressure, the system will shift to the right to the side where it has fewer moles of gas. Because fewer moles of gas will exert lower pressure. So, dia boleh reduce the pressure here. So, now, what is the effect to the final equilibrium? The final equilibrium will have the concentration of reactant will decrease and the concentration of product will increase. Okay? Okay, nanti dia akan capai lah balik QC equals to KC tu. Okay? Alright. Next. Change in pressure. What if the volume increase? So, if we increase the volume increase, so now the pressure will decrease. Kalau volume increase, pressure decrease. Betul? So gas pressure immediately decreases. So, QC is not equal back to KC. They're not at equilibrium. So, what will happen? The system will reduce the disturbance by increasing back the pressure. Macam mana nak increase the pressure? It will move, the equilibrium position will shift to the side where it has more moles of gas. So in this case, it will shift to the left. Okay, because the reactant side has more molecules of gas. Okay, kenapa dia pergi shift to the more moles of gas? Because more number of moles of gas side can exert higher pressure, sebab dia nak increase pressure kan. So bila dia akan increase more pressure, the equilibrium can be re-established, can be re-achieved. Okay, so dekat sini what will happen to the concentration of the reactant? It will increase, then the concentration of the product will decrease. Okay, so look here. Tengok ni ini system at equilibrium. Okay, adalah Q equals to K, system at equilibrium. Okay, so bila tengok ni bila dia ada higher pressure, dia ada smaller volume, dia akan shift to the side where dia ada fewer moles of gas to reduce the pressure. Okay, dia akan move to the side where it has fewer moles of gas in order to reduce the pressure. Okay, bila dekat lower pressure pula, dia akan move to the side where it has more moles of gas in order to increase the pressure. So, dia punya cara macam tu je lah. Okay? Alright. Next. So, look at here. So, tengok ni. Kalau kita increase pressure, kalau changes di increase pressure, sistem akan cari usaha untuk decrease balik pressure. So, dia akan pergi, equilibrium akan shift to the side with fewest moles of gas to reduce the pressure. Sebab apa? Lagi sikit moles of gas, lagi dia akan exert lower pressure. Excuse me. Kalau kita decrease pressure, dia akan pergi ke side with most moles of gas untuk increase balik pressure. Sebab apa? More, lagi banyak moles of gas, lagi tinggi lagi pressure, betul? Okay, sama juga kalau kita increase volume, maksudnya kita decrease pressure. So, dia akan pergi dekat, so yang ni sama lah, sama, okay? Yang ni sama, yang dua ni sama. So, kalau kita decrease volume, dia akan increase pressure. So, dia akan pergi kepada side with fewest moles of gas. Okay? Alright. What happened? Okay, so let's look at the exercise here. So, consider the following equilibrium system. Okay, predict the direction of the net reaction in each cases as a result of increasing the pressure. So, increasing the pressure on the system at constant temperature. So, kita kira dulu number of moles of gas. Kalau nampak pressure, kita kira number of moles of gas. So, tengok yang ni. 2 campur 3, so kita ada 5 moles kat sini. 2 campur 2, 4. So, kalau kita increase pressure, kalau kita increase pressure, sistem akan cari jalan untuk decrease pressure. So, macam mana kita nak decrease pressure? Kita kena equilibrium position akan shift to the side yang ada fewer moles number of molecule. So, in this case, dia akan shift to the right. Because kat right ada 4 je mole. Ni dekat kiri ada 5. So, the equilibrium will shift to the right to decrease the pressure, kan? Sebab apa? Side dekat right ni dia ada fewer moles of gas molecule. Kalau dia fewer moles of gas molecule, bermaksud dia akan exert lower pressure. Okay? So, let's look at this one. B. Ni ada 1 mole, yang ni ada 2. So, dia akan exert ke mana? Dia akan shift to the left. Sebab apa? To decrease the pressure, the equilibrium position will shift to the left with fewer moles of gas molecules, because fewer moles of gas molecule will exert lower pressure. So, the pressure will decrease, kan? So that dia boleh achieve balik equilibrium state dia. Kita tengok C pula. C dia ada 1, 2 molekul. Ni 1, 2 molekul. So, dua-dua ada 2 mol, 2 mol. So, what happen? there is no change. Sebab apa? Tak ada side yang berbeza. Okey, kalau katakan reactant punya side dengan product punya side, dua-dua ada number of moles of gas molecule yang sama, untuk pressure dia tak ada change, no change. Sebab apa? Diorang dah ada dekat equilibrium state dah, even though kita increase pressure pun. Okay? Alright, next, last one. Dekat sini kita ada 2 moles of gas, ni ada 3. So kita akan proceed to the left. Sebab apa? Left side dia ada fewer moles of gases which can exert lower pressure, which will hence reduce the pressure. Okay? Alright. So, ni pun sama lah. Okay, kat sini pun. How would you change the pressure? Via a volume change the following. To decrease the yield of the product. Oh, how would you change the pressure? Via a volume change. For the following reaction to decrease the yield of product. Because sekarang ni dia punya dia punya objektif dia adalah untuk decrease product. So kalau kita nak decrease product, maksudnya kita kena shift reaction to the right. To the left. To the left, so that dia akan consume product to form more reactant. So that will decrease the yield of product. Betul? So, apa yang kita boleh buat untuk So kita akan change the pressure. So kalau gitu, dekat sini kita ada 3 mol. Dekat sini kita ada 2 mol. Dekat sini kita ada 4, 7. Dekat sini kita ada 8. Dekat sini kita ada 1. Kita ada 1 juga sebab gas tak kira kan. Okay. Sebab gas pula. Solid tak kira. Mian ni. Solid tak kira. Sorry guys Sebab solid tak kira. Solid yang tak kira, bukan gas yang tak kira. So, sebabkan solid kita tak kira. Kita akan kira satu-satu lah. Okay. So, sekarang ni, kita nak reaction tu shift to the left. To the left dah lah. So, kalau kita nak kena buat apa pada volume change tu? Okay, kalau kita decrease the volume, kita akan increase the pressure. Betul? How would you change the pressure? How would you change the pressure? So, maksudnya kalau kita decrease the pressure. Okay, kalau kita decrease the pressure, sistem akan cari jalan untuk increase the pressure. So, kalau kita increase the pressure, kalau sistem nak increase the pressure, okay, dia akan shift the equilibrium to the side where it has more moles of gases. So, in this case, dekat bahagian right ni ada higher moles of gases sebab nak increase balik pressure, betul? Okay, so dekat sini number A, dia akan decrease the pressure so that the system will increase the pressure and shift the equilibrium to the side with more number of moles of gas. Okay, tengok yang ni pula. Kalau kita increase the pressure, sistem akan cari jalan untuk kita decrease the pressure. Okay, so kalau kita nak decrease the pressure, kita kena shift equilibrium position to the side with fewer moles of gas. So untuk B, yang ada fewer moles of gas adalah 7. So kat sini kalau kita increase the pressure, the system will shift to the side with less moles of gas to reduce the pressure. So untuk B, cara dia adalah increase the pressure. Untuk C, no effect langsung sebab dua-dua ada 1 mole of gas. So tak ada effect. Okay? Alright. So next, kita tengok addition of inert gas. So, inert gas ni adalah gas yang dia tak reaktif. So, kalau kita add pun, dia tak akan react dengan reactant atau dia tak akan react dengan product. So, the total pressure of an equilibrium system can be changed without changing its volume by adding an inert gas. However, adding an inert gas has no effect on the equilibrium position. So, the effect of the addition of an inert gas to the equilibrium can be studied based on these two conditions at the constant pressure and at constant volume. Okay, kita tengok. So, kalau kita add inert gases at constant pressure, maksudnya pressure kita sama je. Pressure same. Constant. katakanlah kita ada gas kat sini, 2 gas kat sini. Okey. Ini reactant, ni produk. Okey. Kita ada partial pressure lah. Okey. So, bila kita add more inert gas kat sini, inert gas, pada pressure yang sama. So, maksudnya, pressure total sama. Equals to pressure reactant campur pressure reactant 1 campur pressure reactant 2 campur pressure product campur pressure inert gas. Okey, tadi kita ada ni je initially sebelum tambah inert gas, pressure partial pressure of reactant dengan product okey. Tiba-tiba kita tambah pressure kita tambah inert gas. So sekarang ni total pressure still remain the same. Tapi bila kita tambah inert gas, sekarang ni partial pressure of reacting species ni, partial pressure akan decrease sebab due to the addition of inert gas. So nampak ni. So the partial pressure of the gases in the system are lowered. So now the net effect is as though the gases at equilibrium are subjected to a lower total pressure. So, according to Chatelier's principle, addition of a noble gas favours the direction that increase the number of moles of gas. So, kalau kita tambah inert gas, dia equilibrium position akan fix the equilibrium by shifting the equilibrium position to the side with more number of moles of gas in order to increase the pressure so that the partial pressure of the reactant and product kembali seperti biasa. Okay, will increase lah kan, so that the partial pressure will increase. Sebab apa kan partial pressure dah decrease disebabkan oleh addition of inert gases. Okay, so if we see here, okay, we have PCl3 gas and PCl3 gas and chlorine gas react to form PCl5. So kat sini ada 2 mole of gases, kat sini ada 1 mole of gas. So kita punya gangguan disturbance kita adalah addition of inert gas. So asalnya P total dia initially at equilibrium, P total kita equals to PCl3 plus partial pressure of chlorine plus partial pressure of PCl3, PCl5. Okay. Okay. However, at inert gas, okay, sekarang P total kita telah termasuk PCl3 plus PCl2 plus PCl5 plus partial pressure inert gas. Okay. Maksudnya, this partial pressure has been lowered. Okay. So, total gas pressure decreases. So, equilibrium position akan shift to the side with more moles of gas in order to increase the pressure. Okay? So, in order to increase the pressure, the system will shift to the side with more number moles of gas to increase the pressure. So, the system will reduce the disturbance by increasing the number of gas molecule proceeding to the left. So, bila kita proceed to the left, less product will be produced, more reactant will be produced. Okay, so PCl3 and Cl2 will increase and the concentration of PCl5 will decrease. So, the equilibrium will favours the reactant. Okay? Alright. Boleh faham? Okay? Macam dia student je. Alright. Okay, so macam tu lah. Sebab apa? Disebabkan bila pertambahan noble gas menyebabkan partial pressure of reacting species lowered. So, sistem akan cari jalan untuk increase the partial pressure. So that, dengan cara dia pergi ke side yang ada banyak number of moles of gas to increase the pressure. Sebab apa? The high moles of gas will exert higher pressure. So that is why lah. So dekat sini, in this case, dia akan shift to the right. Shift to the left. Sebab apa? Reactant lagi banyak moles of gas compared to product. So as a result, the concentration of product will decrease and the concentration of reactant will increase. Okay? So which means that the equilibrium favours the reactant compared to the product. In this case lah. Okay? Alright. So, kalau kita add constant pressure pula. macam kalau untuk case ni pula, dia akan favor product. Sebab apa? Product ada more moles of gas. So bila kita add inert gases, partial pressure of reactive species akan decrease. So sistem akan cari jalan untuk increasekan balik partial pressure. Macam mana nak increasekan partial pressure? Dia akan equilibrium position akan shift to the side with more moles of gas, which is in this case product ada more moles of gas. So the so the system will shift to the right. So in this case, the reaction will proceed to the right. More product will produce. So the concentration of hydrogen gas and oxygen gas will increase, and the concentration of water will decrease. Okay, so in this case, equilibrium favors the production of product. Tadi reactant sebab reactant ada banyak mole of gas. Kali ni product sebab product ada more number moles of gas. Okay. Okay, what happen kalau the addition of noble gas tu at constant pressure tapi kedua-dua reactant dengan product ada moles yang sama? Okay, dekat sini kalau dua-dua side ada moles yang sama, 2 mole contohnya, equilibrium position is not affected because dia punya moles of reactant dengan product dah memang sama. Okay. Okay. Kalau kita add inert gas at constant volume, kalau volume constant, okay, the total number of gases molecules increases. So, kalau volume tu sama je, okay, volume constant, maksudnya dia tak akan berubah. Dia tegak je. Dia memang tu je. So, contoh asalnya kita ada produk dengan gas. Produk dengan reactant. Okay, bila kita tambah inert gas, so sekarang ni total pressure akan increase. Okay, so bila total pressure akan increase, so partial pressure akan remain unchanged. Sebab apa? Sebab total pressure increase. Okay, tengok contohnya macam ni. Kita ada total pressure kita, product, partial pressure of reactant. Okay, initially. Okay, bila kita tambah partial pressure, tak boleh dekat sini. So, bila kita tambah partial pressure product, bila kita tambah inert gas, kita akan dapat partial pressure reactant and then partial pressure inert gas, betul? So, dekat sini disebabkan volume dia constant, bila kita tambah lagi banyak gas kat situ, total pressure akan increase. So, bila total pressure akan increase, dia tak akan effect pun lah partial pressure ni. Sebab apa? Partial pressure product dengan reactant tadi akan remain unchanged. Sebab apa? Total pressure increase disebabkan oleh pertambahan partial pressure inert gas tadi. Okay, sebab volume constant kan? So, maksudnya bila volume constant, makin tambah gas, makin tambah gases molecule, makin tambah total pressure. So, maksudnya dia tak effect pun partial pressure product dengan reactant tadi. Sebab apa? Disebabkan total pressure increase. Okay? Kalau yang tadi sebelumnya, pressure dia constant. So, bila pressure constant, walau macam mana pun, partial pressure product dengan reactant akan kurang disebabkan ada pertambahan lagi inert gas. Tapi sekarang ni, in this case, pressure meningkat disebabkan oleh volume still the same. So, maksudnya partial pressure product dengan reactant itu tak terganggu disebabkan pressure akan menaik bila kita tambah partial pressure inert gas. Boleh faham ke? Okay? So, macam itulah. Okay, so dekat sini, bila partial pressure remain unchanged, okay, dia tak ada effect lah dekat equilibrium position. So, therefore, the addition of inert gas at constant volume has no effect on the equilibrium position and the composition of the equilibrium mixture. Okay, so tak akan ada perubahan. Dia tak akan pergi dekat mana-mana side lah. Okay, alright. So, it does not change any of the quantities. Okay? Alright. So, no change. So, bila kita add inert gas at constant volume, there is no change happen. Okay. Let's look at change in temperature. So, tadi, semua faktor-faktor kita baca tadi, factor concentration, factor pressure, factor inert gases, diorang langsung tak ubah equilibrium constant punya value K. Diorang cuma ubah position of equilibrium concentration at equilibrium. Tapi diorang tak ubah value of K. However, temperature here, dia can change the value of K. Okay, dibagi, so maksudnya, the change in temperature affect the value of K. So, kita tengok kat sini. So, in this case, this forward reaction is exothermic. Dia release heat. So, bila dia release heat, the production of product form will release heat. Maksudnya, reactant react to form product and heat. Okay, so this is exothermic reaction. Okay, heat release. Okay, kalau reaction tu dia absorb heat, dia adalah endothermic reaction. Contohnya PCl5 dia absorb heat to form PCl3 dengan Cl2. So maksudnya ini adalah endothermic reaction, heat absorb. Okay, kita nak tengok case untuk endothermic dengan exothermic reaction. Kalau kat sini tengoklah ni. Okay. This is the case where heat is released. So this is exothermic. This is the case where heat is absorbed to form product. So this is endothermic. Kalau heat release, awak nampak tak energi dia berkurang? Kan heat release? Heat release? Kan tak? Kalau kita absorb heat, energi dia bertambah. Sebab apa? Heat absorb. Okay? Alright. So, lupa nak cakap. So, kalau exothermic, delta H dia negative value. Kalau endothermic, delta H dia positive value. Okay, now, kita tengok exothermic reaction. So, exothermic reaction is the reaction where the heat is released to the surrounding in forward reaction. Okay, so maksudnya kita akan bebaskan heat energy. So, delta H equals to negative 11. So, katakanlah kita ada disturbance, kita increase in temperature. So, bila kita increase the temperature, sistem akan cari jalan untuk kita reducekan balik temperature tu supaya dia boleh kembali untuk achieve balik new equilibrium. So, macam mana dia nak reduce temperature? Okay, so, dia akan absorb heat. So, equilibrium position akan shift to the left to absorb the additional heat. Macam mana? Bila produk ni react dengan heat, dia orang akan form balik reactant. So that is why to reduce the temperature, the system, the equilibrium position will shift to the left to absorb the additional heat. So reaction will proceed to the left so that it can absorb the heat. Okay, boleh Okay, kalau kita drop temperature. So, kalau katakanlah reaction dalam sistem tu, temperature decrease. So, sistem akan cari jalan untuk naikkan balik temperature, untuk increasekan balik temperature. How? The system will proceed to the right so that when the reactant react to form product, it will release more heat. Kan? Betul tak? So that it can increase balik temperature. So, dekat sini, untuk reduce disturbance, the reaction continue, proceed to the right. Okay, apa maksud exothermic reaction is favourable, exothermic reaction is not favourable? Kalau reaction tu proceed to the right, maksudnya heat release, exothermic reaction is favourable lah. Macam tadi, reaction lagi favor, pergi patah balik, pergi absorb heat. Sebab apa? Kenapa dia absorb heat? Untuk reduce temperature kan? Kan betul tak? Sebab temperature dah naik. So, sistem akan cari jalan untuk reduce temperature. So, bila untuk reduce temperature, produk kena absorb heat to form reactant balik. So, kat sini, dia akan shift to the left. So, dekat sini, exothermic reaction is not favourable. Sebab apa? Dia absorb heat pula. Kan? Okay. Okay, so tu je sebenarnya. Dia favourable tak favourable je. Depend on dia buat apa. Okay, next. Kalau endothermic, heat kita absorb. So, maksudnya, produk reactant kita akan absorb heat to form product. So, in the case where there is a rise in temperature, kalau temperature tu naik, sistem akan cari jalan untuk reduce temperature. So, untuk reduce temperature, dia akan proceed the reaction to the right, where the reactant will consume the additional heat to form more product. So, in this case, endothermic reaction is favorable. Kan, saya dah absorb heat kan? Okay. So, dekat sini, the reaction will proceed to the left, to the right to reduce the temperature, to absorb the additional heat. Okay. How about when we decrease the temperature? So, bila kita decrease the temperature, sistem akan cari jalan untuk increase balik temperature. Macam mana? Sistem will shift the reaction to the left. Ni salah ni. To the left, okay? Maksudnya sebab supaya bila produk ni react, dia akan release more heat. So, bila dia akan release more heat, temperature of the system akan increase. So, that is why the reaction will proceed to the left. Okay. So, dekat sini, endothermic reaction is not favorable lah kan sebab dia release heat, betul tak? Okay. So, dekat sini, kita tengok in forward reaction, disebab forward reaction, sebab dia plus heat, betul tak? Plus heat. Sebab dia exothermic kan? In forward reaction, dia exothermic reaction sebab dia release heat. Negative sign kan? However, reverse reaction, dia endothermic sebab apa? PCl5 absorb heat to form reactant. So, dia endothermic. So, maksudnya kita bercakap, forward reaction is exothermic and the reverse reaction is endothermic. Okay, so dekat sini kan saya cakap temperature akan affect the change in temperature will affect the value of K. So, for example, tadi, bila kita increase temperature, sistem akan cari jalan untuk kurangkan temperature tu. Macam mana dia akan absorb heat tu. Heat tu kan dekat belah produk. So, produk akan absorb heat to form more reactant. Kan? So, dia akan net reaction to the left. So, bila reactant lagi banyak dari produk, kalau ikutkan, K is equals to product divided by reactant. So, bila reactant increase, K akan decrease. Product akan decrease, betul tak? Dia inversely proportional kan dengan reactant kan? So, bila dia akan, kalau dia shift to the left, maksudnya reactant akan banyak lagi form. Value of K akan decreases. Okay, kalau kita decrease temperature, sistem akan cari jalan untuk increase balik temperature. So, in this case, untuk exothermic reaction, dia akan shift to the right. Sebab apa? Kalau kita shift to the right, dia akan release more heat. So, produk akan form lagi banyak. Kalau produk form lagi banyak, value of K akan increases sebab dia directly proportional. So, value of K is directly proportional to the concentration of product. Betul? So, dekat sini, K will increase but product increase. Okay. So, temperature decrease favors an exothermic reaction. Sebab apa? Temperature decrease, dia lagi dia akan favors to the right lah. Pergi to the right. Kalau pergi to the right, dia akan release heat. Sebab itu exothermic reaction favors the decrease in temperature. Okay, supaya the equilibrium position akan shift to the right to produce more heat and product. Okay, to release more heat and product. Okay. However, kalau endothermic pula, okay. Kalau untuk case endothermic kan absorb heat. So, maksudnya heat dekat sini, dia akan absorb heat. So, maksudnya in forward reaction, dia akan endothermic. Reverse reaction, dia akan exothermic sebab dia release heat kan. From product to reactant, dia akan release heat. Okay, katakanlah kita increase temperature. Sistem akan cari jalan untuk decrease the temperature. Kalau decrease the temperature, kita akan absorb additional heat lah. So, dekat sini maksudnya sistem akan shift to the right. Betul? Sistem akan shift to the right. So, dia akan form more product. So, kalau dia form more product, value of K dia akan increases. Okay? So, kalau kita decrease temperature, sistem akan cari jalan untuk increase temperature. So, dia akan shift to the left. So, bila shift to the left, product punya formation akan turun. So, bila product menurun, K pun akan menurun. So, in this case, we know that temperature increase favors an endothermic reaction. So, kalau sistem tu increase temperature, endothermic reaction sukalah sebab dia akan favor endothermic reaction. Dia akan boleh absorb more heat. Okay? Dia berlawanan je dengan exothermic tadi. Okay? Cuba fahamkan balik. Okay? Alright. Dia berlawanan je dengan exothermic tadi. Alright. So, okay. Okay, this one you can do it with your tutorial lecturer, or you can do it by yourself actually. Cuba praktiskan balik. Okay, Miss nak ajar untuk effect of catalyst pula. So, catalyst dia speeds up a reaction. So, dia akan provide alternative mechanism with lower activation energy. So, dia akan increasing forward and reverse rate of reaction to the same extent. So, which means dia akan short the time taken to reach equilibrium. But remember that catalyst actually has no effect on the equilibrium position and value of K. So, maksudnya dia tak effect langsung untuk equilibrium system. No changes at all. Okay, dia cuma lower the activation energy supaya dia boleh form product dengan cepat. Okay? So, kalau activation energy dia tinggi, lambat nak capai equilibrium to form product. Tapi kalau dia punya activation energy dia rendah, cepat dia dah boleh form product. Okay? Sebab itulah dia shorten dia reaction time. Okay, so catalyst lowers activation energy for both forward and reverse reaction. Okay, so dekat sini, kita tengoklah concentration dia akan ada perubahan dekat equilibrium shift. Dengan apa ni? Equilibrium concentration. Tapi dia tak akan bagi change langsung dekat value of K. Pressure pun sama. Dia tak akan bagi langsung change dekat value of K. Volume pun sama. However, temperature dia akan bagi change dekat value of K. The effect value of K. Catalyst dua-dua tak. Dia tak effect shift equilibrium. Dia tak effect the value of K. Okay? Alright. So, synthesis of ammonia, Haber process. So, ni yang tadi yang formula N2 plus H2 to form ammonia gas. Okay, itulah Haber process. So, nitrogen can be found in many essential natural and synthetic compounds. So, richest source of nitrogen is atmosphere because 4 of every 5 molecules are nitrogen gas. Okay, however, due to the low reactivity of nitrogen gas, the supply of usable nitrogen has become limited. So, nitrogen atom is very difficult to fix combined with other atoms due to the strong triple bond that hold the two nitrogen atoms together. Okay, walaupun banyak nitrogen gas, tapi disebabkan dia punya low reactivity. Sebab apa? Nitrogen gas ni sangat stable. So, apa stable? Ada 3 triple bond, ada 3 bond yang diorang bind together untuk form N2N. So, sangat-sangat stable dan sangat-sangat tak reaktif lah. Okay, so dia akan ada Haber process to form ammonia gas. Kalau tak boleh form ammonia gas kan? Sebab apa? Nearly 13% of nitrogen fixation on Earth is accomplished industrially through the Haber process for the formation of ammonia. Sebab kan, kalau nak tunggu nitrogen gas tu dengan semula jadinya form ammonia, memang tak akan form sebab nitrogen gas sangat-sangat stable dan low reactive. Okay, so dia kena buat secara industrially. Okay, through Haber process. So, kita akan ada nitrogen gas react with hydrogen gas to form ammonia gas. This is exothermic reaction. Ya, exothermic reaction negatively kan? Negatively negative punya sign dekat delta H2. Okay, so the process was developed by Fritz Haber, German chemist, in 1913. So now over 80% of this ammonia is used in fertilizer applications. Okay, so the application of equilibrium principles in the Haber process. So to make an industrial process economically worthwhile, so there are 3 ways to maximize the yield of ammonia. Okay. First one, kita decrease NH3. So, kalau kita decrease NH3, sistem akan cari jalan untuk shift the equilibrium position to the right in order to increase the formation of NH3. Okay. Kalau kita decrease the volume, kita increase the pressure. Tengok ni. Kat sini ada 3 mol. Kat sini kita ada 2 mol. So, kalau kita increase pressure, sistem akan cari jalan untuk decrease balik pressure by shifting the equilibrium position to the side with fewer moles of gas. Because fewer moles of gas exert lower pressure. So, bila equilibrium position shift to the right, dia akan produce more ammonia. Okay, and lastly, kalau kita decrease temperature. Okay, disebabkan dia adalah apa kita cakap? Exothermic reaction. So, kat sini kita ada plus heat dekat sebelah sini, okay? So, kalau kita decrease temperature, sistem akan cari jalan untuk kita increase balik temperature dalam sistem. Macam mana? By proceeding the reaction to the right. Because if we proceed to the right, the system will release more heat so that then the temperature will increase again. So, these are the 3 ways to maximize the production of ammonia. First, by decreasing the concentration of NH3. Second, by decreasing the volume or increasing the pressure. And lastly, by decreasing the temperature. Okay, so all of this is use the application of Chatellier's principle. Okay, so look at this one. If we decrease the NH3, okay, kita akan remove ammonia. Bila kita remove ammonia, sistem akan produce more ammonia untuk capai equilibrium state. Okay, so equilibrium akan shift to the right. Okay, kalau kita increase the pressure, kalau ni 4 moles, ini 2 mol. Sistem akan decrease pressure by shifting to the side with fewer moles of gas. Betul tak? So, decreasing the volume will shift the equilibrium towards fewer moles of gas so that it can produce more ammonia. Okay? Kalau kita decrease temperature, okay, formation of ammonia is exothermic. Plus heat dekat sini. Okay? Kalau kita decrease the temperature, the decreasing temperature will shift the equilibrium to the right to release more heat and to produce more ammonia. Okay? So, Kc will increase as well. Temperature je akan effect K kan? So, sebab tu ada Kc will increase. Okay? So, however, ammonia forms slowly at low temperature that the process become uneconomical. So, high pressure and continuous removal are used to increase yield. But the temperature is raised to moderate level and a catalyst is used to increase the rate. So, dekat sini disebabkan ammonia ni dia akan form sangat slow kalau dekat low temperature. So, dia sangat-sangat menjadikan satu proses tu tak ekonomi lah. Dia banyak berguna, ongkosnya banyak kan. So, dia akan untuk mengurangkan itu, untuk increasekan formation of NH3, dia akan gunakan high pressure and continuously removal of NH3 so that dia boleh increase the yield of ammonia. Tapi, temperature dia akan naik dalam moderate level. Dia tak akan naik dengan terlalu tinggi. And dia akan tambah catalyst to increase the rate of the reaction. Okay? So, keep in your mind that in Haber process, low temperature will increase the yield of ammonia. But the rate of reaction will be too slow. Okay? So, the ideal condition is... Allah, kenapa ni? So, ideal temperature is 450 to 500 degrees Celsius untuk maximize yield and the rate. And catalyst will be used iron to speed up the reaction. And use the aluminium oxide to increase the catalyst efficiency. So, promoter ni adalah untuk increase the efficiency of the catalyst. Okay, and pressure sangat-sangat tinggi. 200 to 1000 atm to save cost. Okay. Benar dia? Okay. So, yeah. So, this is the key stage in the Haber process lah. Daripada H2 dengan N2 gas pergi compressor. and then react in the catalyst bed to form NH3. Dekat ammonium condenser ni, sama macam ni, form NH3. So, dia akan storage. So, macam ni lah dia punya formation of Haber process. Ini boleh buat sendiri, okay? So, I think that is all for today. We have finished chapter 6.3, Lee Chatelier's principle, and I hope that you can understand this chapter. I know it's a bit, this 6.3 chapter needs a bit more on the, korang kena faham. Korang kena faham concept. If you can understand the concept of this Lee Chatelier's principle, semua soalan akan jadi senang. Sebab apa? Kalau faham, boleh macam, kalau ni increase, dia akan shift ke mana? Left ke right? Macam tu, kan? So, the key point dia, you have to understand. Okay, if you don't understand, please let me know, okay? Ask me personally to PM me dekat Telegram, okay? I will get back to you. Okay, so that is all for today. Thank you for watching and have a nice day. Bye-bye. Assalamualaikum.